Shri Rajendran graduated in Civil Engineering from Regional Engineering College, Tiruchirappalli, along with a postgraduate diploma in valuation. He is presently pursuing his doctoral program in valuation of heritage buildings and heritage monuments. Shri Rajendran has 37 years of experience in the field of civil engineering and is a specialist in offering cost-effective techniques, repairs and renovations to heritage buildings and monuments. He has been a visiting faculty in many universities and is one of key resource person for AICTE, that is All India Council of Technical Education, since 1990. Shri Rajendran has conducted many seminars and workshops for architects and engineers. He is presently the Managing Director of Adi Parashakti and Associates, along with his son, Shri Shakti Murugan, who holds a postgraduate degree in conservation from School of Planning and Architecture, New Delhi. Their firm primarily specializes in conservation works of heritage monuments, heritage structures, and offers exclusive designs to construct cost-effective buildings and homes across India. Dear Rajendran sir, we request you to please commence your talk on engineering perspective of Chola temples. Thank you.
Thank you. My prayers to my Guru and my thanks to Mr. Gurumurthy and the Rotary Club of Coimbatore Metropolis and Professor Swaminathan, then my teacher and Guru, Mr. Dr. Kodavai Balasubramaniam, and my friend Mr. Vidilinadana Acharya and Mr. Umabadi Acharya, with all whom I am actually working together. It's a great privilege to be here and talk about Cholas, engineering aspects of Chola. I think I enjoy this type of, talking about the field where I am trying to explore. And still I am trying to find the end of it. It's such a vast area. Whenever I go for this type of search, I come out with a new solution or new findings. So let me share the experience of what all I've undergone and what all is still left outside. See, this is the right side, a photograph I've taken along with Dr. Kodavai Balasubramaniam about 12 years back at Madigai Mede in, that is Gangaikonda Cholapuram. The next one is recently I've gone there just to verify how the conditions is. And so in that, one strange thing I noticed is, I think most of the civil engineers here, any civil engineers here? Any architects? Okay. See, in this, a strange thing is, I've not seen any queen closer, kandikal they call it. They cut the brick into quarter and put it in between to arrange the staggering the joints. They do that. That I have not seen in this. So, the modular ratio of bricks are used very well in this. The width of the brick and the length of the brick is used very perfectly. So the offsets of the brick, a group of brick pier or whatever you call it, a platform, varies about 7 inches, 3.5 inches on either side, the offset. And the brick we found there is totally different. We'll be seeing it. And the foundation, what you see is underneath, on the left side, is made out of granite, no mortar in that. It's placed one over the other. So it's only an adukumanam, not kattumanam. It's not a building. They have not built it, they have placed it one over the other. From avoiding from the lateral movement, lateral stresses, they have created a ball and, trough socket, ball and cup. The one at the top will have a projection and the bottom will have a trough, a cup-like arrangement. And it was followed everywhere. And some places, the basic construction, some places they've used even lead to keep the column. See, these are the brickwork taken from Gangaikonda Sodapuram. See, the mortar is only mud. You could see this. This is a mud mortar done with a fermented mortar. They would have had a lot of things in that. As per Tirupani Malai, and I got it from Dr. Kodovail Balasubramaniam, Nellikai, that is, your amla, and then black gram, and kadakai, nutmeg, then tanikai or something they sell it. All these things are made into powder, and then they've allowed it to soak for some time, and then they've added that in the lime mortar. So to ferment, that was the combination they had used. And see, here they've used not lime, only mud. They've used mud in this, and the whole palace building was resting on this foundation, mind you. The foundation width was about 4.5 feet. After the offset of about 7 inches, it was 4 feet 1 inch. And it comes up to the plinth level. Above the plinth, they had used bed blocks to make the pillars stand. That's the simple principles. See, coming back to the great Chola edifice. See, the foundation, what we had, this is, the thing is assumed, but we have seen it in Dharasuram, which had a long granite slabs, to a depth, thickness of about, length of about 12 feet, thickness about 1.5 feet, width about approximately 1 feet 9 inches or 2 feet. That has been arranged in a manner in one direction in the first layer, one layer. The second one is a perpendicular direction. Again, the third layer is again the same direction as it was in the, odd numbers or even numbers. You can take that way. That is the foundation technique they adopt. This is nothing but what we call it a raft at this period. Now what we do as a raft. The raft foundation is nothing but for the whole building. They excavate and create a RCC bed. On that RCC bed, they create, they make the walls and other things. So that any differential settlement, the whole building will adjust, the foundation will adjust. Similar type of foundation they have used. And mind you, they have chosen a place where there was totally a lime deposit. Limestone deposit was there. And it actually gave them a freedom of taking so much of load on that. What was the, soil mechanics knowledge? What was their engineering knowledge? We don't know. Because I leave the rest, to your imagination. They must have been number one. There is nothing equal to this, structure in the whole world. I can say proportion or whatever you say, massing, whatever the architectural jargon you use, space, the architectural thing they say, what is the definition of architecture? Many points makes a line, many lines makes a plane, many planes makes a space. The whole edifice, the structure, it's, blemishless. It is, the perfection is so good. The slope, verticality, the size, the massing, the scale. You can go on telling about this. This is the best. Nothing can come near this. I don't know how we missed this, structure in the world wonders. This should have got into the world wonders. Somehow we missed it. We should try to get that into a world wonder status. This is an engineering marvel. We can say it is an engineering marvel, and then a spiritual glory, an architectural, whatever you call it, it's totally different. In any aspect you can analyze. This is number one. And see this is another thing, the engineering terminology you say is a compression member. See, when we use steel, you know where we use steel? Only when the member is a tension member. To take the tension, we use steel in concrete. Concrete cannot take tension, so we introduce steel, a foreign body inside concrete. That time there was no steel when they invented. That time the span or the concrete was not there. Cement was not there. Lime was there. They had used only lime and they had converted that into a compression member. The whole thing is a compression member. That's why the temple was inside hollow up to the top. So simple example is a coconut shell. Take two coconut shells. You can just put it inverted, the bottom portion facing down. A person of 80 kilos or 75 kilos can stand on that. How it is possible? Because the load is transferred along the slopes to the ground, the shell. That same technique he has adopted. The total load comes to that. Again, that load is distributed between these two walls. This technique, I'll come later for this. So, the square is made into an octagon, 16 or like that polygons. Many polygons, and finally it end up in a curve at the top. Very simple. He has used all simply supported, no tension member in that. It went on reducing the diameter. Finally, it ended up like this. And see the joints. The technique here they had used is carbelling. Projecting that material just outside. We call it cantilever. This is a carbelling technique. Continuously stones are placed like that. There was no mortar in between that. Whole thing is placed one over the other. Coming back, foundation, I had said that big temple, then this is Dharasanam. See this. Again, this proves, there is no mortar joint. It is placed. See the joints. 1 year, 1 year, 1 year, 1 year. It is staggered. This is a whole stone, single stone. This is a whole stone which bends also. So like that, the actually placing of stones were so perfect, so much, the engineering aspect. It is done so nicely, they were able to place it. And they never, what my assumption is, they would not have done it or ready-made, like modular standards. They would have brought a stone, after seeing the size of that stone, they would have made it fix in that. Or they would have selected another stone to match this corner, so they would have gone for that. Similarly, they would have brought the stone there, then after checking the size, they would have fixed it. But you cannot make a brick like, standard sizes and place it. That is not possible. But that is the only way they would have done it. See here, see this size, and no single stone is similar. It's different. No two stones are similar. It's different. So, naturally, they would have taken that in random. All must have got some standard, length. If it is little bit smaller, 6 inches smaller or 5 inches smaller or 5 inches bigger, they would have adjusted that according to the placement. So in the placement they have done it. And see the settlement, due to some reasons, doesn't matter. This settlement can be easily repaired again. Remove that again, refix it. So this is not like RCC. Where RCC, once the problem starts, it again, we call it cancer in concrete. So the corrosion takes place, it becomes useless. You have to go in for a new material. Now the rebarring technique has come. We use sophisticated, epoxy, glues. We fix it inside. So those things are possible now in a RCC building. But all those things you don't require for this to repair. This can be dismantled again, repaired again without any problem. That's the beauty of it. Again, say again foundation. I think about these things, Mr. Umabadi Acharya would have explained all these elements. Foundation, you have lot of, architectural elements. Everything is required for that place. So, for that, they have used that stone. Here, you could see some different grading of stones. See, this is different, this is different, this is different. That's why I said they must have got the stone, placed one or the other. When it is raw, you won't be able to make that much of difference between color or anything. They would have placed it, and after dressing, they would have seen that color difference. But they have left it as it is. So, all these things are after placing one over the other, they would have carved this. See, everywhere it is like that. The joints are even. And the material is different. See here, this joint and this joint are not in the same line, slightly different. The stone must have been like this, slight curve. They would have done it. Now, this is the inside wall, western side wall of Brihadishwara temple, Sanctum Sanctorum, inside. You see the lines here. It is not horizontal. I think my theory, assumption of having different stones on different level, I think all these things made me think in that line. See this. It's not horizontal, but still. And another thing, if you do this way, this will have a resistance for the lateral movement. That is also there. So that's an advantage. See here, this stone also, not in one line. This goes up. See this. See here, this is in Gangaikonda Chodappuram, how the stones are used. See another, this is a lintel. The thickness is so big to avoid the tension. If it is small, it may deflect, it may bend, it will fail. So they have taken care with the thickness. So this is simply a bed block, again a bed block, and over that they have put a thing, and this is a floor. How they have done it. See the walls, they have done it like this. Two sides dressed stones, and in between they have filled the wall gap with lime mortar. The strange thing I noticed in Gangaikonda Chodappuram is that the lime mortar contains a lot of coarse aggregates. We call it small pieces of metal, which glitters. Lot of silica, it glitters. When I removed it piece by piece, I could see the glittering effect in that. I don't know what we are going to do. I'm actually going to take that to Taramani Institute and check up what material they had used in that. And see this wall, you can cleanly see. On either side it's very clean, and in between there's a filling. And see that bonding here. It's not in one line. This is here, the joint is here, this joint is at the top. So, need not be in the same level, but at the same time it should have better binding. That's how they have done it. See, this is a bed block for the next building where they can put a beam over that. This is extension. Probably this is done by archaeology later. They had used this for some other thing. So see this wall. See this shape. This is narrow here, this is wider, and here this is broader, this is narrow. This itself retained against the lateral movement. Even if there is a mild tremor, this will retain it. This will take care of these things. And another, say this, a smaller temple. This is in Dharasuram, how they had gone it. How they have made this broader, wider opening into a polygon, again inside, like this. They have taken it down. And some of the smaller areas, they have put flat stones. And after laying the stone, they have carved it. They have not carved it earlier to that. They have placed it and then carved it. So you have to lie down and then do it. What difficulty they would have undergone, this stabadis. A lot of things. See another, very simple. And the basic concept of these pillars are, normally we say the basic in engineering, the traditional buildings were made out of posts and beams. Pillars and then beams. The slab itself, a flat beam is a slab, that's all. Imagine a beam to be very flat, it becomes a slab. So similarly, there is no mortar in between. All these things are placed on a dead white. Only the verticality is maintaining that. The load passes through the center of the pillar. See another Coimbatore, beautiful brickwork. Nothing is equal to this brick. See, they have done the carving in the brick. Look at this. Look at this. These things are, they have done the carving and then they have placed. Brick is different. Stone is different. But see this brickwork. See the joints here. And this type of brickwork resembles something near Bali or Chola dynasty's work. The brickwork resembles, this brickwork resembles that brickwork. There is some correlation in between. Something has happened. Probably same artisans must have done it. Or somebody who knows the brickwork technique is same. Phenomenal. The mortar thickness is like paper, less than a mm. That is what they used to call it, sagadam teital. They grind the brick on either side, apply a paste of lime, fix it, you cannot remove it. We tried that in one of our traditional building repair now, and in that we could see that we were able to, at least achieve 10% of what Rajaraja achieved at that period. It is, to our satisfaction, we attempted that. And again, when there was no steel, beams were available, the caps were filled by carbling. They gradually project this and bring it to the top and close it, and then over that they use it. The same technique was adopted, has been adopted in all the Chola structures in Brigadishwara temple also, between two walls. And the Sanctum Sanctum, above that, the Gopuram, they've done it like this, the Vimanam or Gopuram, whatever call it. Some in that we could see timber also, well-seasoned timber. And in the timber, in one of the constructions in Pabanasam, Tirupalaturai, we have noticed, they have wound the wood with, coconut fiber rope with a lime mortar over it. They have just wound it over that and placed it on the wall. And this is the carbling, beautiful example of carbling. This is a stone carbling. This is again stone carbling. This is a brick. See this, how it goes, how the thing gets reduced, space. And now coming back to this is a theory, I think, well explained by Dr. Kodawal Balasubramaniam. Our temple was, originally, it was like this. What you see is only this. Because the invasion, they have demolished these two tiers. And what we see is only this as a complete. This is drawn to the scale. It is like this. And that should have been over by this. 3 tiers must have been there. But we have only 1 tier now. And this is a cross section of that. So all these things are done by French architects, French people. We have not done anything. That's, I don't know, the government, French government gave the, scholarship, and they spent the money to document our temple. That's a paradox. See this. See the walls here. One wall here, the inner wall is about 13 feet, outer wall is 11 feet, and in between is about 8 feet. The corridor, the later one gets reduced. Again, the carbling. The first one ends up with a corbel and then a stone beam. And another, this goes up again. The whole, this load takes the whole structure load. This is the wall. That is transmitted through 2 walls, concentric squares. The load is distributed. Again, this is a hollow structure. You could see this. Again, same thing. The inner is 11, outer is 13. In between is 6. See, the stone you have seen. And another one, vault, in Tiruvadaimarudur. There was, somebody was asking whether it belongs to Mughal tradition or something. But this is about nearly 850 years or 900. See the vault here. A brick vault. It is wider at the base, at the top it is narrow. It is done with total bricks. It is exposed, still existing, without a damage. Without any damage. Excellent. There is no water leakage, nothing. It's done with lime mortar. This is a beautiful thing. The same similar technique we have been trying, and we have been doing in some of the renovation works. How we do it, just see. This is a flat arch, we call it. Some of the Maratha buildings, we have this type of flat arches. Some of the roofs, they have this type of flat roofs with bricks placed like this. And there is a segmental arches, very shallow arches. There are a lot of shallow arches in the dome, in roofs. And this is a very circular dome. How the circular dome is done, there is a radius is maintained. When you rotate it's at 360 degrees in half the, sphere, you get this. How we do it, you'll see. There's also another detailing, two-point vault. The Thirudamardur vault is something like this. And how a dome is done. This is a 18 feet dia dome. I had done up to 48 feet dia domes without reinforcement. So this is done like this. The bricks are placed parallel to this line. That's all. You can go on doing it. This will converge at a point. This is for Ramalingadigal or Madam, Menyana Sabai, this is for a meditating hall. We have done that. And in one of the temples we did this vault repair. That is mainly given by Mr. Umabadi and Mr. Vellinathan Acharya. They were doing the work and I was helping them in solving this vault problem. See how the vaults junctions have been done with brick. All these things are done with lime mortar. See some of the, even I had suggested granite, this type of, you have to make a stone like this and place it over that. Once you place this, this becomes a compression member. Nothing can remove. An elephant can walk on that top. Only you want to break it, you have to break it from base. The simple example is you take an egg shell. When the chick is inside, when you want to break the egg like this vertically, when you hold it, break it, you cannot do it. The same egg, when a chick inside with a soft beak breaks it from inside. So the arches and the vaults are weaker from inside. When you apply pressure here, this fails. When you apply pressure at any amount of pressure at the top, nothing will happen. Very simple. Shell technology is only that. And that, in that technology, we were very good. We were doing so much work. I don't know how, from where they got. It's, simply we can say it is a native wisdom, but at least that wisdom must have started from somebody else, somewhere. We are searching for the point where it has started. See, this is another, the temple had 3 walls. See, we were using grinders, commercial grinder to grind the lime and sand. And the client, it was from a trust. They wanted to make a miniature, a prototype vault. We made a prototype vault. See here, both of them, Acharyas, both of them are here, and another architect, they are doing it. See, we have done that. One is over, another 2 nearing completion. The inspiration is only from this. We got it from Thirudamardur. Now, there is another marvelous, as I said, which the basic concept of post and beams. This is exactly, explained in Gangaikonda Sodapuram. See the pillar, and this doesn't have any deeper foundation. It stands on a bed block. And then over that, this is again a bed block at the top. This load is transferred. Probably the load in this must be around 8 tons, approximately 8 tons. It is able to withstand. Very simple. All these pillars are done like that. The only difference is, in pillars, they do the carving, they do the sculpture work, then they place it. Not like others, not like a Brihadishwara temple. Here, they do the work and then place it vertically. But one thing, they must place it really vertical. Otherwise, that will fail. There will be eccentric loading. It won't be able to take, it will fail. So that, I think that the execution must have been very good. So that's how all our, see, you could see the thickness here. It's only half the thickness of this whole pillar. The total load is transferred. See, another marvel at Brihadishwara temple, the cantilever. We call it cantilever. See, if you see, Simple example of a cantilever is, you stretch your arm and stand for a few minutes. How long can you stand? 5 minutes? No, because the pain will start here, radiating pain. The same thing the building undergoes, fatigueness, stress at that point. So you have to counter that. They have done it. This is a see, independent unit. Every unit is placed one next to the other, and a counterweight is kept on that so that it doesn't topple. Very simple. If you want to dismantle this building, it is possible. We can dismantle it and reassemble it. Very simple. We have all the equipments now. That time they didn't have anything. They never had all this. But they had done it with a shorter period. And that too, they had worked from morning 6 to evening 6. Only in the daylight they would have worked. And they had done all the pre-stress, precast. It is something similar to precast material. Precast, now the technology, precast technology is you make all the building components into smaller thing and make it in a factory or somewhere else, bring it to the site and place it one or the other, either lock it with whatever the grout or the bolt and nut, you do it and make it stand. But he has done without even a single pin. This is the whole thing is a cantilever. This comes to 7 feet. Imagine 7 feet it is thing. Look at this. This is interlocking. All these things are interlocking. See, this is a beam which initially supports it, and then over that there will be a counterweight on that. See this. The corner will have a maximum stress. Here you see this. How the element has gone beyond the length. See here. And see the column especially designed to take that load. Everything aesthetically done, but it has got an engineering thinking and an architectural thinking. All in one. Amazing. If we go on explaining, there is absolutely, we can, till our lifetime, we can go on explaining these wonders. See this, another. How interlocked. This is a separate beam which stands over this. And then this is interlocked. This one beam will be there and 2 joints will be there like that. It is linked. The same concept near Kilapalur, one very old building, probably around 850 years old, with a complete tree. A banyan tree is over that, and then Nilippa tree, whatever they call it. 2 trees are over this building. The tree, only the big roots goes through the wall, and it actually that feeds the tree, and it is the total load is taken on that, and there is only initial settling is there. See this. This can be again repaired. See this, where the column stands, no hold in that. Look at this. Look at this. And now coming back to this again, Gangaikonda Sodapuram. These were the bed blocks for the pillars, where they had placed the pillars. See there is a socket, a trough there. Can you see the mark of the beam column? You can see all the marks of the column. This is still remaining in that site. And that same building, look at this. Look at this. Again the precast elements, like same technique. Individual elements placed one or the other with a counterweight at the top. Look at this. See, it's still hanging, but still it holds the whole tree. It doesn't have roots anywhere, only through these gaps it goes. Now, this is another small mandapam. We wanted to experiment. The 2 students who are doing masters, first year MSc structural engineering, I asked them to analyze the total stability of the building. And they wanted to use StatPro. We were not able to come to an answer. StatPro is not able to go beyond certain level. It's actually, it can work out with a steel and other conventional building, but it cannot work beyond this. For this, we have to again design a software for this. Very simple. See, a top load, it is a separate beam-like thing at the top, and then it's again a beam with a slab, and it stands on a bed block, corner block, and then a round pillar, And then over a stone, again a stone. It is closely packed. We have done the, work on this, and we have found out manually when we work, we are able to arrive, this is safe. A small example, we wanted to work on that. And another amazing temple, which many are not allowed, because always the temple is kept under lock and key. I don't know for what. This is maintained by Archaeological Survey of India. It is near Kilapalur, Rattai Koil. This is called Rattai Koil. This is also about Rajarajan's period. And see this, everything is done with stone. And then there is a Kalasam also with stone. And very beautiful, on lot of details in that. I took the photograph from outside the compound, from long shot. Now coming to jollies. You have seen how the walls are built, roofs are built, and now coming to the jollies. See what type of jolly they had. This we call it an engineering term or architectural thing, we call it jollies. See how they have done it. All these things are manually done. See the design, it has got a lot of intricate designs in that. It is placed in between, this is a window. And the same thing, see here it is done by machine, water cutting. It's done at Madurai. They are actually the biggest granite factory in the world. That they come in second in the world, next to Brazil. There they use the water as a cutting tool. They cut it. This is only 12 mm thick. This is 18 mm. This is 20 mm. You see this, how intricate they have cut it. This is possible now, but this doesn't have a human touch in that. The feel is not there. What you see in this, you don't get in that when you do it with machine. See, this is, again, they are using water. Now, this is a surprise to many. See, all our children are studying in their textbooks. The shadow doesn't fall. Nidalsaya Gopuram, big temple, the shadow falls. I had taken it about nearly 12 years back. The shadow falls in that. It is cleanly, see this. The first one you may say is digitally manipulated. But so that's why I was very careful. I took the shrine with this. The original concept is, throughout the 365 days, during noon, 12 o'clock, the shadow doesn't fall outside the base of the building. That is outside the base of the structure. That is the thing. Uchi Vayilil Nidalsaya Gopuram. Because the base is wide, 100 feet by 100 feet square. The top is 24 by 24 square. When the Uttarayanam, Dakshinayana, you know that sun travels from one direction to another direction. 6 months it goes to the northern end, and again next 6 months it starts from north to south. So on those 365 days, at noon, the shadow doesn't fall outside. So, but all our textbooks, I had even informed the textbook society, chairman. They said, what you said is correct, but we have given a letter also to change that. Nothing has happened. Still it is going on. See, shadows in different stages. We took for nearly 45 minutes, 1 hour. Another, see, another marvel. This is rainwater harvesting. We talk now. We say we are the people who do the rainwater harvesting. 1000 years back, Rajarajan has done the rainwater harvesting. See, the whole temple, this drain. And now today, Dr. Kodavayil Balasubramaniam has come out with another, finding. He says there is one more drain on the, opening on the northern side, west. This is on the western side, northwest only. This is on the northern side, there is another vent. See, here, when the rainwater gets collected, you insert a wooden plate so that it blocks the exit of water. And water is retained inside the temple, and you can clean it. Then afterwards you can pull it up, water runs off. So it goes to the Sivaganga, near that, pond and gets filled. So, and another thing he said is, the slurry, the one side direction, in one direction if you open, the slurry goes first. Another direction if you open, only the water goes. So that level difference, hydrology also they were very good in hydrology. So whatever field you take, they were good. We have so much speciality now. Everything we have a speciality. If like medicine, engineering also coming to that level. If you are, totally initially about 30 years back, one doctor will see everything. Now, just for a year, inside the year there's another doctor. For that it goes on doing, widening. So, engineering also, but that time they had the knowledge of everything, totality. That is the beauty of it. And now, as Mr. Sriraman said, we had worked on for a PhD for a person, for the Vice Chancellor of Periyar Maniamma University, we did an observation. In that, we had come out with this type of proposal, 1 in 15 slope, which is normally used in overbridges. That same slope has been maintained. When you maintain that, in 1.5 turns, it reaches the top. And you require only 600 feet on either side, all sides of the temple. If you fill that area with mud, that 600 feet at the base, an angle of repose, we say, when you keep a heap of sand, it slides at level and it maintains certain angle. If you maintain that angle, you require only 600 feet on either side, and you can go on filling it, and fill the inside also, and you can walk around and go climb up to that level. It's very simple as that. And when we calculated the volume of earth, which they would have used, that comes to the level of, the volume of Sevapanayak and Eri. We had done that also. We did a survey there, we calculated the depth, we calculated the volume of earth, it is same. So maybe we are zeroing it at it. We'll see. It is for the researchers, you can work on it, think about it, come out with a solution. Now, I think I've said something, and before concluding, I would like to stress another thing. See, there was one important aspect of thing I missed. The big temple, when you enter, the first and the foremost astonishing thing about that temple is the door jamb. We call it Nelappadi, which is about 40 feet height and 4 by 4. The dressed stone is 4 by 4. They must have got at least 9 inches or 1 foot extra on either side. So 6 by 6 to a height of about 40 feet or 45 feet. From where the 4 pillars are there, from where they would have got it, how they would have got it, after bringing it, how they would have dressed it, after dressing it, how they would have kept it vertically. There was no hoist, no lifters, no cranes, nothing. They had done everything manually, and it is perfectly vertical. They have placed it vertically. The entrance, that is the amazing thing. Initial, like that you have lot of things in that, and every entrance you see the big temple, and when you go to that small shrine in front of Amman Sannadhi, you see through that, you see the whole temple. So everything is framed. For a photographer also, it is a feast for photographers. You can take anywhere, it is framed by a traditional building frame. So it is like that, and it's, I thank Mr. Gurumurthy for the chance you have given, and I enjoy talking about this wherever I get a chance. And I think, any questions that you can ask me? No, it's not a single stone. It is. I had the opportunity of climbing over that in the last, 2010, August 30th. When I climbed over that and I was standing next to that Kalasam, I felt as though I was standing at a place where Rajarajan was standing. And the Rajarajan's son Rajendran, incidentally my name also coincided with that. So it was a great feeling. I saw the whole city, whole town of Tanjavur from there. I climbed that from outside scaffolding in 18 minutes. It was a God-sent offer. I thank the God from that point. It was a great opportunity. I felt so good. It is a marvel, and it is, see, lot of myths about big temple. But it is, they have done it with the simplest procedure. That's the beauty. But we have not gone to that level. We have not propagated that points. So it's better we talk on that line hereafter. Its foundation is only about 1.5 meters. That's all. It's only one, that's a great thing. 1.5 means 5 feet. Can you imagine 5 feet foundation? The simplest technique they have adopted, raft. That's all. Thank you.
Thank you very much, sir.